To add flow monitor and rain gauge data to Flowbot, simply use the menu items from the menu bar. The data will be imported and added to the appropriate list of available monitors. To view monitor data in the flow, depth, velocity graphs, simply drag a monitor to the plotted monitor window and drop it. The graph controls can be used to view the data in more detail. New in version 3 is a change to the default behavior when you drop a monitor into an existing plot. It now will replace the current monitor to create a new graph. If you want a multi-monitor view, then simply select and then drag and drop multiple monitors. Individual monitors can be removed by using the context menu for that monitor. All monitors can be removed simultaneously by using the context menu for the monitor group. A graph view can be limited to a specific event view by dropping an event into the plot view. This will lock the graph navigation bar. Scatter graphs are created by dropping the appropriate data into the plot view window. Using the options dialog, you can view the scatter plot of depth against either velocity or flow. Some of the plot options will be disabled if there is no model data associated with the monitor. Model data can be manually entered for each monitor if desired. If model data has been imported to Flowbot, then it can be associated using the pipe reference. To import ICM data, simply use the import function from the model data menu. The import data format is a CSV saved from a model links grid. To associate model data to the monitors, use the edit monitor function from the model data menu. This table can be used to manually associate the model data. Alternatively, the export/import mappings functions can be used to save or load previously mapped data. Reviewing rainfall in a cumulative depth view is useful as it can highlight spatial variation and/or missing data. Specific events can be reviewed by dropping them in the plot view. Dropping all the rain gauges into the rainfall event analysis view will cause Flowbot to review the rainfall data for each gauge against specified event criteria. The histogram and Gantt chart plots provide a visual indication of when and how many of the gauges meet the event criteria. This view is the most appropriate place to capture potential rainfall events. Event criteria can be modified as shown. The modifications will have an associated impact on the charts. To classify flow monitor data, simply drop the required flow monitors into the plot view and hit refresh. This will update the random forest classifier and create a visualization of the daily monitor classification and the associated classifier confidence. New in Flowbot 3 is the ability to create flow monitor schematics. Imported flow monitors and rain gauges can be dropped onto the schematic canvas. Schematic items can be moved individually or as a selected group. Basic network asset items such as pumping stations, CSOs, junctions, outfalls, and treatment works have been provided to allow the model network to be represented in the schematic. Schematic items can be connected using the connection tool. Connections can have intermediate vertices to allow bends. A more complicated project can be imported to demonstrate the functionality of the schematic. Upstream and downstream tracing can be performed from any schematic item. This allows the user to identify which assets have potential impacts on monitors and vice versa. A volume balance check can be performed for any of the flow monitors. This will calculate the total volume for a flow monitor and compare it to the total volume of all of the immediately upstream monitors. The difference between the two values is shown in brackets. Negative flow balance is indicated by a red-colored value. New in Flowbot 3 are the verification review tools. ICM trace exports can be imported to Flowbot and analysis performed on them. Once a file has been imported, simply drop it into the plot view window. The basic plots are similar to those normally created in ICM with observed and predicted traces and a table of statistics. Each of the available verification locations can then be reviewed either by double-clicking on the item or by using the next and previous plot buttons. Any individual location can be given a verification score for depth and flow using the context menu as shown. Similarly, a verification score can be requested for all of the locations using the Group Context menu. A traffic light scoring system can be seen for all of the trace locations, with the reddest colors indicating the poorest level of verification against UDG criteria. It can be seen in this first example that the traces are meeting all criteria except time of peaks. This is not entirely correct, as the second peak is somewhat overpredicted. However, the peaks do coincide temporally. Flowbot allows the user to edit the peaks. By increasing the number of peaks to 2 and smoothing the observed data to reduce the noise, we can correct the time of peak issue. This causes the peak depth to be out of criteria. However, this is a more correct state of affairs. A similar exercise can be performed for the flow verification trace. We have swapped it from being a timing issue to a peak flow issue, but again, this would likely be considered more correct. One of the intended workflows for Flowbot verification analysis is to quickly review all of the monitors and highlight the ones that are needing most attention. The user can set particular locations as critical in order that the more stringent UDG criteria are applied. Here we can see that FM09 meets UDG criteria as a general location, but not as a critical location. A second intended workflow is to help document verification and produce review materials for quality control and audits. While not yet a fully robust documentation system, Flowbot 3 will allow the user to make notes against flow, depth, and overall verification fits. These notes are used in the reporting output of Flowbot. Outputs and reporting has been improved in version 3. The first verification report that will be generated here is the trace outputs. Use the configuration dialog to add a title to the report and to select which imported trace file to print. All, none, or a subset of the verification locations can be selected for inclusion in the report. Finally, a file path is selected and the report is ready to be generated. Here we can see the generated PDF report. The next report demonstrated here is the verification summary report. The configuration dialog is used to add a report title and to select the desired ICM trace file. Again, a file path is selected and the PDF report generated. Here we can see the generated PDF report. The final report shown here is the verification detail report. It is created in the same manner as the others. Here we can see the generated PDF report. The verification comments added during the Flowbot review can be seen in the bottom right-hand side. As well as formatted reports, raw CSVs can be exported that allows the user to perform further analysis or format the charts in a way they prefer. The imported observed and predicted data is output as well as the smooth traces, peak points, and Nash-Sutcliffe efficiency scores. There are similar reporting outputs for the flow survey analysis element in Flowbot 3. These encompass the FDV graphs, the scatter graphs, the flow volume balance, and event suitability. Also raw CSV outputs for FDV, scattergraph, and cumulative rainfall plots.